This is a short lesson about chemical and physical properties. Physical properties are those that are determined without altering the chemical makeup of the material. So anything that you can observe or measure and not change the elements or molecules that something is made out of would be a physical property. So size, shape, color, density, odor, whether something is malleable, which means you can flatten it into sheets, or if it's brittle, which means it breaks when you hit it, or if it's a good conductor or not. Those are all physical properties. Chemical properties are involved with transforming the substance into a new material. For example, if it reacts with acid or base, if it reacts with water or air, if the material is corrosive, or if it's flammable. Those are all chemical properties. In a physical change, the identity of the substance is not changed. What it's actually made out of, the atoms and molecules stay the same. Be sure that you know that melting or boiling are physical changes. Dissolving something is a physical change because when you take the solvent away, you get the original material back out again. In a chemical change, you have to have a new substance formed that wasn't there before. So the identity of one or more substances change and one or more new substances are formed. Some examples that you might see when a chemical change takes place include the formation of a gas, so you see little bubbles, or a solid, maybe some little chunks of material formed together. That's called a precipitate. You might see a color change, a change in the surface of a solid material, or even a temperature change because some chemical reactions are endothermic and some are exothermic. Endothermic reactions feel cold. Like if you have a chemical reaction that takes place that's endothermic and it's inside a beaker, when you hold the beaker, it feels cold to your hand because the energy is leaving your hand and going into the system. And exothermic would be like fire is a chemical change that gives off energy, heat, and light, so it's an exothermic reaction. Let's do a little practice with these. You don't have these page numbers, but let's practice with the ideas. Okay, metals, when they're pure, have a high luster. Is that chemical or physical? That one is physical because you can look at it and see whether it's shiny or not without changing its chemical makeup. Some metals may become dull when exposed to air. Well, think about a nail. If a nail rusts, it's forming iron oxide. So that's a new chemical, so that's a chemical change. Nitrogen gas, which is a relatively non-reactive gas at room temperature, can form nitrogen oxides at the high temperatures of an operating automobile engine. Inside your gas tank, when air goes into the gas tank and it does what the combustion engine does, it combines the nitrogen with some oxygen and makes nitrogen oxide. And since a new compound is formed, that's a chemical change. That means that nitrogen gas has the chemical property of reacting with oxygen. Milk turns sour if left too long at room temperature. Yuck! If you've ever tasted sour milk, you know what I'm talking about. The reason why it tastes sour is the formation of an acid, and acids being formed means that this is a chemical change. That means that milk has the chemical property of undergoing that change. We'll do some more at school, but that ought to get you started.